Bismillahirrahmanirrahim. So today we deal with the normalization. But before we discuss normalization, let's first, see the memory map. See our map. Where are we? So what we said in the beginning, what we did in the first place, we have to first, we have a problem domain, that is your UOD, which is your problem domain, the problem you have to solve, for example banking system or whatever. So that will be your UOD, right? This is my UOD. So you have to first select the UOD, that is the problem itself, where you have to develop something, a database you have to develop for a bank, for example, and all. So then we started making out of it, because we said first it has two requirements, right? One is a functional requirement and another is the database requirement. In the database requirements, it's a software engineering phenomena. First we do the analysis. That's not concept schema. First we do analysis, that what the problem is, okay? After that, out of that, when we do the analysis, what the problem, etc., out of it, the analysis, we will make a conceptual design, and that conceptual design was actually your ER diagrams, right? So we made ER diagrams. That was your conceptual design, which tells us everything about the system, what our system is and all, right? What kind of entities we have, basically, what relationships we have between the entities, and what are their attributes. So this will define what is the of which you have to store the data, of which which entities are there. Entities itself mean that you have stored data of these things, that we are basically identifying. And the basic thing is entity relationship, that you are going to store data about the entities and their relationships, right? Then it is all piece of paper that we say that this is a conceptual design, and we start making ER diagram on a piece of paper. We are done with the design phase. Then we need a model. We need a modeling. So next step was modeling, and in the modeling we chose what? Relational model. So relational model was our next step. That was what we are reading until now. Very relational model and all, relational algebra and a lot of things. So because model, when we say model, it basically has three things, right? What is the three things we have? First is the organization of data, okay, or data structure, or data structure you have, and we say the organization of data we have is a tabular structure. It's a tabular. We have the tables where tuples and attributes and all. We said we have degrees, we have cardinalities. We discussed a lot of things about it. Then also in a model we need to have what operations we can do. And for that we did our relational algebra, okay. Even we have a tuple calculus also. Yes, we don't do that here in BCA, right? But we did relational algebra. It was all about operations. Some operations we are doing all the time. And you can also put some constraints. What constraints you can put on your data, right? So you first define the data, then what operations you put on the data, and what constraints you put on the data. This overall is called a model, and the model we chose was the relational model, right? A relational model was something which was defining all these things, and we did it successfully. Now when you are done with the relational model modeling, right, you need to have but this model, now what we have chosen, the model, it should not have any problems. It should be correct. It should be consistent. it should not have what in a shortcut I can say, it should not have any anomalies. So it should not have any anomalies is a key. To remove any sort of anomaly, what kind of, we'll see there are anomalies, what kind of anomalies we have. To remove the anomalies, we have, that means we are now tuning this model. We are trying to tune this model now so that it becomes perfect, consistent, error free, no anomalies, and that thing is called as normalization. The remedy is the normalization. It was done by the cord itself and the boys later on, who applied normalization on its, because relational model was introduced by the cord, and he also put up the normalization to make it perfect. And then there come later on called boys, who introduced a few things more. We'll discuss that. But what is the basic funda here is, when we make a table, making a table is not enough. Okay, you can make a table, but it will have a lot of anomalies. We'll discuss these one on one. But first visualize why we do the normalization and all. If we have a, let us take an ER diagram here. We were discussing previous time also. This is an entity and we have some relationship with the guy like this, right? And then we have another entity here. Say for example this is a student, okay, this is a course, okay, so student is enrolled for a course, something like that. This has a course information, this is a student information, and it's enrolled. We said in the beginning that database reduces redundancy, but there is a control redundancy. The control redundancy is done by the normalization, because we said in the beginning that file based approach uses different files for different things, right? So it has to store a lot of things, there is a lot of redundancy, a lot of files are to be stored about a particular thing, so it can have a problem. So then we got an idea like this, that we can create a table here, which has all information in it, and then we get things from that table only. So whatever database I have, for example, I am taking a simplified version here, that student enrolled for a course, for example. If I have only this thing, for example, if I have only this thing, I make a big table. I make a table, the things which comes in a mind to make a big table, and it seems that it will reduce all the redundancies and it will be a good thing that we put a student information on this side, say student ID, okay, right, then name, okay, there could be other things also like course ID. Then no need to write it, because I guess we have the note on that. So course only concentrate. I will go to the note again. I will go to the note and we will see that. So course ID, course name, instructor, who is teaching this guy, this course, and the office. This is the perfect example which will suffice all normalizations. Okay, up to the 3 and this will be a good example. So this comes in mind that we will have a big table which has everything in it. Then I want, for example, anything out of it, I can get it. Course, I will do projection or selection or whatever, and I will get the things. But this table is full of anomalies. This table is full of anomalies, right? So what kind of anomalies we have? What are the anomalies? So anomalies could be either insertion anomaly or deletion anomaly or updation anomaly. That means if I make a table like this, it will have a problems of insertion, problems with deletion, and problems with updation. Are you getting me? So let's go to the node and with this info. So what I am saying here is basically that if you have a student enrolled course like this, and you have an intuition that we will put big table, then it will save a lot of things. We do not have to repeat things and all. but it's not like that. It is having problems, so we have to split. Normalization means actually to split this table into the many tables, so that we remove the anomalies. Okay, and there is a normalization is some stepwise. First NF, 2NF, 3NF, then BCNF, 4NF, 5NF. In the latest one is a 6NF. Okay, we'll discuss them all. Let's go to the node. So this is a normalization. So this was our table. This is the table that I'm talking of. But we don't have an ER diagram here, so you can build your ER diagram here. Like you say, this is a student, right? And this is a course, and offered is the relationship, right? Student versus course versus offer. So we start making a full table. This is example from some book we have taken. Okay, you getting what I'm saying? Now this is enrollment, this is name, this is address, course number, course name, instructor, and office. So we try to make a one big table which has everything in it, all information. But let us visualize the, if you understand what are the anomalies in it, we are done with the normalization. You will understand very easily how to fix it with the normalization. What is normalization? What I said? To split it, to split this table into many. Why? To remove the anomalies. So what are the anomalies? First, the first anomaly what I am seeing here is the update anomaly. Which anomaly? Okay, here is my cursor. This is the update anomaly. That if you want to update something, you will have a problem. Same as like a files. We discussed like files. If you have a telephone number many places and you wanna update, maybe you will. Okay, as you could see here, that listen, this is a student, for example Rahul or whatsoever. His address, and this is the course number which he is joining, and other guy also is also in the same course, and this course MCS 014 is being taught by Preeti Anand. Okay, and SSAD is the course name. I don't know what SSAD will be. SAD maybe I will say SAD, System Analysis and Design. Okay, whatever. So now, if for example tomorrow, so that means there could be hundreds of students with the SSAD, and we are seeing that SSAD is going on, and there will be Preeti Anand who is teaching it. So it could be that now Preeti Anand is no more in our college. She has left, and it is some other guy, right? It is some other guy who is teaching now. Say we have a Faz Zan who is teaching now. So I have to change this into the Fazan. I have to change this into the Fazan, and this could lead to this could be anywhere in the table, isn't it? This Preeti Anand could be anywhere in the table, because the students who are with this course SSAD could be anywhere in the table, and there could be many. You can imagine it simply. There could be many students who are with this course, and not necessarily that they are sequentially. They could be spread up in a table. एक यहाँ पे है, एक यहाँ पे है, एक यहाँ पे है. हर जगह तो हमें change करना है अब. Preeti Anand is no more, but we can easily forget to change, isn't it? We can easily forget to change it. So उससे क्या होगा? आपका data inconsistent बनेगा. That is what is here. I guess if I could find my cursor, yeah. Here is it. Data is inconsistency इसमें हो जाएगी. Why? You can miss someone. You tell me. ठीक है? तो कहीं तो miss भी हो सकता है. So this is what is called as update anomaly. But this table is suffering from update anomaly, because I'm trying to update and it's not getting updated everywhere, because inside my data is redundant. Again, redundancy is the mother of all evils here. We thought that we combine the whole table into one. We will not have a different tables. We will make a one table, but in a one table inside I can have a problems like this. Okay, what about the insertion anomaly? If the second is, you got it with update anomaly, perfect. The second one is insertion anomaly. Okay, you want to insert, but there could be problems like this. For example, if you look at this table, what will be the key, primary key of this table? Enrollment number. Listen, because this table basically has two informations, right? That is the problem with this table. Tomorrow we could have a, if we have this sort of idea that we will make a one table of a whole database, then table will have all kind of informations. Here I'm having a simple scenario of student versus course. I'm having two information. One is student, this side is student, this time we have course. So merely saying enrollment number, particular enrollment number, this enrollment number will tell us uniquely who is this student and what is his address, right? But it can't tell what is the course number, what is the course name or instructor and office. Though, so enrollment number is not sufficient primary key for this table. So it will have a composite key. This table will have what? It will have two in its primary key. It will have two. One is enrollment number, which will define me what student information all, and a course number, which will do what? Information about the course. Because if I say course MCS011, it will uniquely tell me it is this problem solution course, and it is this teacher teaching it, and which has the following office. Are you getting me what I'm saying? What? So this table will have a composite key as a primary key. It will not have a primary key, it has a composite key, because it has two informations in it. One is student information, one is course information. So enrollment number will uniquely define what student, which student we are talking of, and enrollment number will tell us which course we are talking of. So we need definitely two attributes. Well, that's one enrollment number and one is the course number, to identify our what? To identify our tuples perfectly, uniquely, right? Now, if for example I am trying to have a new course, right? I'm trying to have a new course. For example, I want to have I'm introducing a Java course here in my whatever it is. I'm trying to introduce Java course. So maybe it's MCS something 015. I'm trying to introduce Java course, right? Which is taught by me, and my office is, say for example, somewhere 107, right? You getting what I'm saying? Now, one second, let me move a bit to visualize it perfectly. Okay. So what I'm saying is that I'm trying to introduce a Java course. We have a new course in our college, for example, or whatever institute it is. We have a new course MCS015 Java. I'm trying to put it in this table because I have to put the course in the table to tell in the database that we have a course, but no such student yet has enrolled for it, right? So what is on this side? We have on this side nulls, right? Nulls and all. But what is the key of this table? What I said, what's the key of this table? What is that? Enrollment number and course number. So what I'm putting in the enrollment number here? Null. Doesn't it contradict with our what it contradicts with what? A constraint. Entity integrity constraint. Yes, beautiful. Entity integrity constraint says the primary key shouldn't be null, and I'm having a null here because I don't have any student in this course yet. It could happen, but we have a Java course. We can introduce every day new courses come up, and we introduce new courses, and we are not yet having any students. We will put advertisements and then students will come, but we have the course. Okay, we have done all things, we have set up a department for it, and now we go for admission. Will it be like you will have admission first and then student, then course? No, you will have a student course first and then you will go for admission. But can I put that course here in this table? No, because I have to put the null in the enrollment. But primary key can't take the null, because it may have a problem, because if I want to access this table, I need two keys, two attributes to perfectly identified, enrollment number and course number. But enrollment number is null, so that means it is as good as lost, because if enrollment number, my primary key, is null, I can't get this. You getting me what I'm saying? So what is this anomaly called? Insertion anomaly. So I can't insert on this table. Are you getting me? You can read the definition later on. It may be written here. Insertion anomaly, it's written all, right? You can read it in a perfect manner. So we are having two anomalies here. One is the update anomaly. What was the update anomaly? That we have the Preeti Anand here was many times, and we want to change it. It will make our data inconsistent, because you easily will forget. You will not, because it can be a long table having thousands of tuples, and in that you have to find one on one, where is my Preeti Anand, where is my Preeti Anand. It is firstly hectic, and second thing is you may forget easily, and your data become inconsistent, because one tuple will show that this SSAD is taught by the Preeti Anand, another tuple will show that it's taught by, say, Faizan, then maybe that teacher also goes, another teacher comes, so another tuple is showing something else. So it will be all a fuss. This will not be a persistent data, right? There will be no consistency in the data. It will be all a mess, because one showing other thing, another showing other thing, so it will be worth nothing then. So we will not allow that. Are you getting me? That is why we have the normalization introduced by the code itself. And the third thing is the deletion anomaly. Let's visualize it from the table. See what I'm saying. For example, my student, say for example, or teacher, say for example, Preeti Anand left. Okay, or for example, a student. We was having one student who just maybe there are a lot of streams today. He left our stream and he go to some other college. See, he was doing BC and now he is doing BBA. This could easily happen. So the student which was here in the table, now he is no more in our college or whatever it is, college or institute or something. Say for example, this guy Rahul, he is no more in our table, right? So that means I have to delete this tuple. When I am deleting tuple, I can put the null here and I put here course number. It's as good as what we have said earlier. You can't put null, because if you want, say, to remove the student, but course is still there. The problem solution is taught by Nayan Kumar, something like that. It was the example from some book we have taken, right? So if I want to delete this Rahul, I have to delete this whole tuple. Is it? So this makes sense, because Rahul is no more in our college, so we don't need it in our database. He has left it. Okay, so he has left, so we have removed him from our table. But removal of Rahul has also removed the information, the fact that Nayan Kumar is teaching problem solution. This is also being lost, isn't it? But our Narayan Kumar is there. Are you getting me what I'm saying? Maybe there are some other students who are with the problem solution and that can retain the Nayan Kumar, but maybe we have only one student with this. So if that student goes off, that Nayan Kumar is teaching problem solution is also lost. Are you getting me? So what we are seeing here is, this is a deletion anomaly. We are trying to delete one thing, but it deletes me the other information which I should not have deleted. You getting? So why is this problem coming, all the problems coming? Because we are having two sort of informations in my table. One is about the student one is about the course. So I'm trying to interact, I'm putting it in a one table because they are related to each other, because I know, because there is a relationship. That is why I'm putting them together, because I'm saying Rahul is enrolled to the problem solution. That's why I was putting them together in the first sense. Are you getting me? That because my Aparna, for example, here, listen, for example, Aparna here, is enrollment number, this thing, she is living here, okay, and she's enrolled for this course. That's why I'm putting this thing with her. But it's having all kind of problems. Insertion anomaly, update anomaly. Firstly, I said update anomaly because of redundancy in the data. Then we say insertion anomaly, right? Because if you want to put new things, so we can put nulls here. And deletion anomaly, if you delete one thing, it will delete the other information also with it, because we have two informations with it. If you have to delete one information, it will cascade to delete other information also. You getting me? So this is the problem. This is what we saw in my table. We have a table, but I said making table is not enough. We make a table, but it's full of anomalies. What is the use of it? It will be of no use unless we do not tune it. We have to do tuning, means to make it perfect. It should be consistent. So that is why we go for now the normalization to fix all these problems. You getting me? But before we go normalization, we have to understand functional dependency, because it's all about FD. Okay? And there are many types of functional dependencies. According to them, we have the normalizations. Okay? So what is diagram here is we have an A and we have a B. These are attributes of, say, some table. Okay? And we say B is a functionally dependent on A, that B is functionally dependent on A if each value of A is associated with exactly one value of B, as you could see here. If each value of A is associated, this is same as we have read in the mathematics, a relation, right? The functions also, what do you say, isn't it? That if each value of A is associated with exact one value of B, if you are not understanding this, then let me give you an example of it. For example, we have a table. We have a table which is saying your registration, university registration number, right? And student name and his class, right? Student registration number something 01 something. It's maybe of yours. Okay, so student name is, say, for example, Faizan, and class is BCA second year, right? Similarly, there is, say, for example, something for OS, BCA second year, and so on, 02 something, and there is 03 something for, say, Irfan, and this thing. Now, if I am taking this registration number, this is my A, what I am talking of, this is my this A, okay, and these are the B's, okay. This A uniquely identifies, if I say registration number, this one, this is exactly telling me which B. Is it Faizan? It is not OS, it is not Irfan, it is a Faizan. You getting me? It is the BCA second year, not other thing. First year, third year, MCA, nothing. You getting what I am saying? So if A and B are the attributes of a table, got it? If A and B are what? And if each value of A is associated with exactly one value of B. So if you could see here, listen, 011, whatever the registration number is, it can't be related with other guys. It is only related with this tuple, is it? So this student name, this class. So each value of A, now you can understand perfectly what I am saying. If each value of A, each value of what? Is associated with exactly one value of B, because primary key. So basically it's talking of primary key. So what is this? This A. This is actually a primary key. This will give a better explanation of it. So it's functionally. So we say A function determines B. So what we say is this A is functionally determining B. because this A exactly tells me which B. Is it? So my primary keys exactly tell me which attribute, which other attributes I want to know. So this function determines B. No more confusion, I guess. No. Clear? Sure? Okay. So they are called determinants. They are called determinant. There could be many because they could be composite key. Okay? Sometimes it could be composite key, isn't it? Sometimes it could be composite key because maybe you have comma C here. A and C uniquely determine the all B's, whatever the B's you have. So whatever these are, either is A or only C, it is called a determinant. Okay. And these are the dependents. And what dependence? B is a functionally dependent on A. They are function dependent on A. This is what's called as functional dependency. This is called as what? This is very important to understand if you have to understand normalization, because many people have a confusion with normalization because they don't understand this functional dependencies. Because you are normalization on FDs and to remove the anomalies, what we have read. Getting me? Okay. So now we are talking about types of functional dependency. It could be full functional dependency, right? We could have a partial, we will give an example of each. So we have a full functional dependency, right? And we have a partial functional dependency, and we have a transitive functional dependency. If we have a full functional dependency, it's a good thing. If you have full functional dependency, it will not have problems. But if you have partial or transitive dependency, it will have problems. So what is a full functional dependency, what is a partial functional dependency, and what is a transitive functional dependency? We'll visualize it with our example already here. Now here we have full functional dependency. Where is my cursor? Okay, here we go. Here we have a registration number. Okay, your student name and your class, they are fully dependent on registration number. If you tell registration number, it will uniquely tell which student number and which class. So registration number, you know, determines, is a determinant, and your student, what is this, name and class are fully functionally dependent on the registration number. This is called a full, because if you have some primary key and it is uniquely identifying everybody, all attributes of a table, it's called full functional dependency. Now if you look at the above table, what we have already there, a table there, right? Here we got a table. What do you think here? What do you think in this? Is it a full functional dependency? What is the key here?
There are two keys.
Exactly, there are two keys, right? Okay, let me choose a color. Say red. Now let me choose a different color because we already used it. Say green and a little bolder. Okay, now you tell me, this is your enrollment number, right? We have enrollment number and we have the course number. There are two guys. Now enrollment number uniquely determines name and address, because if you have enrollment number, this guy, it will uniquely tell you who is this Rahul and what is his address, this guy. Can it tell me which course number? No, it is the course number, because that's why I have another key, part of a key. That's why I have two keys here, course number, which will identify the information of the course. So course number uniquely determines name and instructor, not even the office, because office is dependent on the instructor. Office is dependent on what? Course, by saying course number or course name, will not determine what is the office of the instructor. It is the instructor itself. When you say instructor, will identify which office. Where is the office located? Because it is the office belongs to the instructor, and instructor's office doesn't belong on a course. Course can be taught by some other teachers also, but they will not have the same office. It is the instructor whose office it is. So if I am teaching it, I will have this office. So my course number will not determine the office. It is me as an instructor who defines my office. You getting me? Similarly, if you other instructor who, so office is being determined by instructor, not by the course number. So what I'm having a situation here is that my course number and course name, my course number determines course name and instructor, and my enrollment determines student name and address. So I am not having a full functional dependency, rather I am having a partial functional dependency, because my all attributes are, what is my key? First thing is, what is my key? My key is enrollment number and then we have a lot of things here. We have student name, right? We have what? Yes, so let me remove a bit this clutter here. Okay, so what I am saying basically is that I am having a student name, we have address, right? This enrollment number determines student name and address, right? So these are not fully dependent on the key, which is a composite key here. This is the half of the key, they are dependent on the half of key, and the course number is a half of key, whereas C name and instructor. No need to write because we have on the note later on, right? And even the office is determined by the instructor. This is called as partial dependency. That my attributes, these all attributes are not dependent on a full key. Here I have a full key, enrollment number and course number, right? So my student number will have nothing to do with the course number. Course number will not identify my which student or which address, because course number, say for example Java, there could be 1,000 students attached to it. So my course number Java will not tell me which student exactly. Are you getting visualizing this thing? But what if I say enrollment number was 01240, 0 for example, it will unique tell me it is that student. Are you getting me? So course number has nothing to, so my student name is not functionally dependent on course number, but course number is my key. This is my A. My A here is enrollment number and B, and these are the B's. So we said that our functional dependency is that, yes, each instance of A uniquely determines which B. And I'm not having that situation here. By saying A, enrollment number, I'm not determining the course name, I'm not determining the instructor. Right? If I say student number 0214, it will tell me what is student name, who is the student, and what is his address. But it will not tell me who is the teacher. It will not tell me what is the course name and all. That will depend on the course name, course number. Course number will determine which course and which instructor. Because course number will tell me, because course number is, for example, we said MCS 014 or MCS 012, it's computer organization. And who is teaching computer organization? Anurag Sharma, for example. And this again is a functional dependency on a MCS 012. So if I am having a composite key, right, and my attributes are not fully dependent on the whole key, but on a partial key, आधी key पे ना, आधी key पे ये dependent है. This is called as partial dependency, and this will lead to us the 2NF and all. We'll see that. Okay. And what about this guy? Instructor and office. What is transitivity? We have seen a lot of times transitivity. If A determines B and B determines C, we can say A determines C by transitivity. Right? Ready me? If like we say, if no need to write, I'm saying no need to write, concentrate. I'm saying B is a friend of A and C is a friend of B. So indirectly A is a friend of C. Right? Getting me? That's called by transitivity, and here it is like that. Let me change my pen. Say color to red. And so office, how it determine which office? By the instructor, right? How it determine which instructor? By the course number. So course number determines instructor and instructor determines office. So indirectly course number determines office. This is called transitive dependence. That you are not directly dependent on a particular attribute, but you are dependent on this guy and this guy for this guy. Then A to B, B to C, then A is determining C. Because now what we are saying that A is determining my B, but B is determining C, so indirectly A is determining C. Because course number will tell me which instructor, and instructor will tell me which office. So indirectly course number is telling me which office, but it is not direct dependence. It is indirect dependence, and this is called as transitive dependence. This is called what? So if we go back to our where we were down, so this is a transitive dependence. A condition where A, B, and C are attributes of a table such that if A is a function dependent on B and B is function dependent on C, then C is transitive dependent on A, isn't it? Okay, B to C, then we say like this: by transitivity, whatever, or transitive dependence. You getting me? Does it make sense? Here we go, the diagram which I was talking about. We have enrollment number. It is because this is our primary key, right? The primary key here is basically a composite one. It is a composite key. A composite key is something in which we have more than one attribute, right? Which can determine all, because I have to determine all attributes, and by enrollment number we can't, by only alone course number we can, so we have to combine the two, right? And just but I'm seeing that enrollment number only determines name and address, course number determines course name and instructor, but instructor determines, so it has all the three, not all the three, two dependencies in it. This is called as partial dependence, and it's called as transitive dependence. What is full functional dependency?
Each key is related to having value.
Yes. Each key determines every other attribute, non-key attribute. All non-key attributes are uniquely identified by your primary key. That is what we want. This leads to our anomalies, what we have seen here. This leads to our anomalies. Because here we have two kinds of information. This is telling me the same thing what I was talking about the table. We have two kinds of information. We have two kinds of information, like we have student information and course information. So we need to somehow disjunct it, right? We need to disjunct it here. We need to crack it here, so that this becomes one table. Now this is full functional dependency. This will become its primary key then. So they are fully functional dependent, and we have to break it also here, this guy, so that this guy will uniquely determine these guys. Then we need some other table to join them up, because to join, you know, natural join, if we do natural join, we need some attribute which is common in both, isn't it? If you have understood natural join, you can understand easily what I'm talking of. Because natural join, we said that we need to have some, like we have the, in that example, which we had what? Assigned to. We had assigned to only for that, because we want, sometimes we want to join this and this. Otherwise we have project information, or we have, what was that? Employee information. But sometimes we want to join them together. Which employee is working on which project, we need an assigned to. So if you break it, but you can't get the, you will lose the information which student is enrolled to which course, isn't it? That information will be lost. Because if you make an enrollment table, student table different, which is enrollment number, name and address in it, but it is lost which student is enrolled to which student. So we need another table. We don't need only two tables. We have to introduce another table, third table, which will tell me the course number and the enrollment number, which student with which course. So three table will do. But then we have to fix this transitivity also, because this transitivity also will lead to anomalies. What are the anomalies? Update anomaly, deletion anomalies. You getting what I'm saying? Sure. Then we go to our normal forms. If you could see here, this is the enrollment number, which is telling me what is my name. Enrollment number telling me what is the address, right? But course number is telling me what is the course name, and course number is telling me what is the instructor, and instructor telling me what is the office. This will give me transitivity. You getting me? Okay, I will stop it here. right? But tomorrow we go to the normal forms. But first, these are what we have read is the tools to understand normal form. If you understood this, normalization is like a piece of cake. It is very easy. You remember right here. You don't even have to learn. If you have not done, if you don't understand these things, then normalization will be like a giant. You understand, hey, what the heck it is. But it is so easy if you understood these things. Okay? So I'll stop here and you just recap this thing.